Good day, everyone. Let's celebrate knowledge by learning science in a simpler way. Before we start with our lesson, let's have a short game named Picture Equation. All right. In this game, all you have to do is to guess the mystery phrase using the given pictures. So let's unlock the first set of image. So the first set of image represents the first word for the mystery phrase, and the second set represents as the second word for the mystery phrase. So let's unlock. So this is in plus best plus T plus gate plus ing. So that's the first word. For second word, this is mo or mo plus men plus number 2, and you add another m, we will have investigating momentum. So our lesson for today is all about momentum. What is momentum? Why do we need to study momentum? We're going to answer that as we study all about momentum. So at the end of the lesson, the learners should be able to first identify factors affecting momentum. Second, define momentum operationally. Third, state the relationship of momentum and mass, and momentum and velocity. Last, solve problems related to momentum. In studying momentum, we may encounter terms that are not familiar. In this game, a jumbled word is given to guess the term being described. Are you ready? Let's start. So this is the jumbled word. Can you guess what word is this? So this is velocity, a vector expression of displacement that an object or particle undergoes with respect to time. That is velocity. Second word. Can you guess? This is mass, the quantity of matter in a body regardless of its volume or of any forces acting on it. That is mass. Third, from the picture itself, this is elevation, the height to which something is elevated or to which it rises. Next one. This is direct. As one amount increases, another amount increases at the same rate. So, what are the factors affecting momentum? Answer: the factors that affect momentum are mass and velocity. What is the relationship exist between mass and momentum? Mass is directly proportional to momentum if the velocity is constant. In this picture, you will see a truck on the left side of the mountain and a bike on the right side. These two obviously does not have the same masses, but if they are moving on the same velocity, since the truck has a greater mass, it will have a greater momentum. If these two collide, the bike will feel the greater impact since it has a lesser momentum. Now, what is the relationship exist between velocity and momentum? Velocity is directly proportional to momentum if the mass is constant. On this picture, we have a race car on the left side and an old car on the right. Assuming that they have the same mass, since the race car moves with greater velocity, it will have a greater momentum. If these two cars collide, the old car would have a greater damage, since the race car has a greater momentum. How will you describe the relationship of mass and velocity to momentum? Mass and velocity are both directly proportional to the momentum. As the mass or velocity increases, the momentum also increases. How will you describe momentum? Momentum is the product of mass and velocity of an object. What is the formula in solving for momentum? Mathematically, we can express this as P is equals to mv, or momentum is equals to mass times velocity, wherein P is the momentum, m is the mass, and v is for velocity. Now, how are we going to get the unit for momentum? Since we have to multiply the mass and velocity, getting the unit of mass that is written in kilogram, and in velocity that is written in meter per second, you're going to combine them. Therefore, the unit for momentum is simply P is equals to kilogram meter per second. Sample problem. A basketball having 2 kilogram mass and 6 meter per second velocity moves to the east. Compute its momentum. So, given mass of 2 kilogram and a velocity of 6 meter per second. So, since we said that momentum is the product of mass and velocity, we can write the formula as P is equals to mv, giving you 2 kilogram multiplied by the value of velocity, which is 6. 2 times 6 is 12, giving you a momentum of 12 kilogram meter per second east. Can you get it? Let's try another sample. A car having 15 meter per second velocity and 1,500 kilogram mass moves to the north. Compute for the momentum. Given you have a mass of 1,500 kilogram, a velocity of 15 meter per second. So formula, P is equals to mass times velocity. So let's substitute mass of 1,500 kilogram times 15 meter per second, giving you a momentum of 22,500 kilogram meter per second north. Can you still follow? Let's have the last one. Compute for the momentum of a child having a mass of 25 kilogram and velocity of 2 meter per second that moves to the west. So as a given, the mass is 25 kilogram and the velocity is 2 meter per second. Using the formula P is equals to mv, 25 kilograms times 2 meter per second. 25 times 2 is 50 kilogram meter per second west. It's very simple, right? But what if mass is missing in the problem? Using the triangle formula, we can put the momentum on top, while mass and velocity at the lower part, meaning we are going to multiply the mass and velocity. We are going to get the mass and velocity in getting the momentum. What if mass is missing the problem? Simply ignore the symbol of mass. This will give you P on the top and V below, meaning the formula to be used in getting mass is P over V, or momentum divided by velocity. So here is a sample. A ball is rolling on a straight line towards you at a speed of 2 meters per second. Assuming that the momentum is 15 kilogram meter per second, what is the mass of the ball? So first thing, write the given. The given momentum is equals to 15 kilogram meter per second and a velocity of 2 meter per second, while we are looking for the value of the mass. So using the triangle formula, how are you going to get the formula for mass? Mass is equals to momentum divided by velocity. So, as a solution, 15 kilogram meter per second divided by 2 meter per second. In this solution, you will see like terms or like units. Therefore, we have to cancel them out, giving you a unit of kilogram. 15 divided by 2 is 7.5. Then copy the remaining unit, that is kilogram. Therefore, your mass is 7.5 kilogram. Now, what if velocity is missing in the problem? So just like the other one, simply ignore the symbol of velocity. This will give you P on the top and M below. Meaning, the formula to be used in getting velocity is P over M, or velocity is equals to momentum divided by mass. Let's have a sample problem here. A cart with a momentum of 12 kilogram meter per second is traveling in a straight line with a mass of 50 kilogram. What is the velocity of the cart? So first, write the given. So you have a momentum of 12 kilogram meter per second and a mass of 50 kilogram. Now let's compute for velocity. In using the triangle, what will be the formula to be used? All right. V is equals to P over M, or momentum divided by mass, giving you a solution of 12 kilogram meter per second divided by 50 kilogram. Since there is like unit, we're going to cancel them out. 12 divided by 50. Done? All right. 12 divided by 50 is 0.24. Copy the remaining unit, that is meter per second. So the velocity is 0.24 meter per second. So let's work out. Answer the following questions. Write your solutions on a piece of paper. I'll be giving you enough time to compute before I reveal the correct answer. Let's work. Problem number 1. A particle has a mass of 10 kilogram and a velocity of 5 meter per second. What is the momentum of the particle? All right, you may now start answering. Don't forget to write the given and the formula. Time's up. The answer? It's 50 kilogram meter per second. Since we are looking for momentum, we're going to multiply 10 times 5, or simply mass times velocity. Problem number 2. A beach ball is rolling in a straight line towards you at a speed of 0.5 meter per second. Its momentum is 0.25 kilogram meter per second. What is the mass of the beach ball? You may use the triangle formula. Time's up. The answer is 0.5 kilogram. Can you still follow? Problem number 3. A 1,400 kilogram car is also traveling in a straight line. Its momentum is 14 kilogram meter per second. What is the velocity of the car? You can use the triangle. Time's up. The answer is 0.01 meter per second. It's very easy, right? Let's summarize the lesson for today by filling the blanks. Momentum is equals to blank times blank. What's your answer? All right, momentum is equals to mass times velocity. The two factors affecting momentum are blank and blank. And your answer? These are both mass and velocity. Mass is blank proportional to momentum if blank is constant. And your answer is? Mass is directly proportional to momentum if velocity is constant. Velocity is directly proportional to blank if blank is constant. It is proportional to momentum if mass is constant. Both mass and velocity are blank, proportional to the blank of an object. So these are directly proportional to the momentum of an object. Momentum is applied for safety devices, like in using a seatbelt and putting airbags on your car. By these two devices, it will help you go back to your proper seat and avoid with the bigger wounds from or bigger casualties from the accident. Always follow traffic signages to prevent accident. With our lesson for today, we have learned that mass and velocity affects momentum. So for your short quiz, let us have a flags up. If the answer is fat, the flag's position would be like this. It's only one flag. But if the answer to the question is bluff, the position of the flag would be like this. Now, let's check your knowledge for today's lesson. Are you ready? Statement number 1. The slower a moving object is the harder it to stop. Is it a fact or a bluff? The answer is bluff. The slower a moving object is, the easier it to stop. Statement number 2. An object at rest has a greater momentum. What is your answer? It is a bluff. Since the object is at rest, its velocity is 0. A number multiplied by 0 would be giving you a 0 momentum. Statement number 3. Both mass and velocity are important in determining the momentum of an object. Is it a fact or a bluff? And it is a fact. Statement number 4. When the mass is doubled, it will cause the momentum increase twice. Is it a fact or a bluff? And the answer is fact. Statement number 5. When the velocity is tripled at constant mass, the momentum increases thrice. What would be your answer? And your answer is fact. It is a fact. For your performance task, make a miniature on how to prevent accidents. And that's all for today. I hope you learned something new and you enjoyed the lesson for today. Till next time.